Okay, so good morning, everyone. As I was introduced, I'm Jeff Cassoff, and I work for MetChem in Montreal. And this morning I'll be presenting the Lac à Paul Apatite Project pre-feasibility study and how I used MineSight to complete the project. So I'm going to start with an introduction of myself, and then I'll introduce MetChem and then go into the project. So I was born and raised in Montreal. I graduated from McGill University in 1999 with a Bachelor in Mining Engineering. Then I went to work at Syncrude in Fort McMurray in the oil sands for 5 years. I was a short-range planner, and I worked in operations a little bit. Then I spent 3 years in Calgary with Norwest Corporation, which is where I learned how to use MineSight. And I've been back in Montreal for the last 4 years with MetChem. And as I said, I've been a MineSight user since 2005. There's a list of some of the projects that I've worked on during my consulting career. Tata Steel Minerals Canada DSO project, which is located in Schefferville. It's an iron ore project. The Ressource project that I'm going to be presenting today, pre-feasibility study. I worked on Ariannes Resources scoping study for the Lac à Telnik project. I've done some work for ArcelorMittal Mines Canada at their Mont-Wright operation. First Bauxite Corporation, it was a feasibility study in Guyana in South America. I've done some work in Mauritania, which is quite interesting, at iron ore mines. Some work for U.S. Steel in Minnesota at Keetac and Mintac. And when I was in Calgary with Norwest, I worked on the Sinenco Energy Northern Lights project and UTS Energy's Equinox project. I'll come over to this side of the room now. So a little overview about MetChem. We are an international engineering consulting firm. It's established in Montreal in 1969. The only office is in Montreal. Our core business is mining and processing. Active in projects covering precious and base metals, industrial minerals, and ferrous metals. Multidisciplinary team with strong hands-on experience in more than 30 countries. And we're currently about 130 employees. The Geology and Mining Department, that's the department that I work in. It's headed by Daniel Gagnon, that many of you know. We do geological modeling, mineral resource and mineral reserve estimation, mine design and mine planning, mine equipment selection and procurement, technical assistant, operation audits and training. We do 43101, SEC, and JORC reporting. And we work on scoping studies, pre-feasibility, feasibility, and EPCM contracts. Currently, we actually have 3 geologists, 7 mining engineers, and 2 mining technicians in our department. Here's a list of the current projects that MetChem's working on. So there's the Tata Steel DSO project in Schefferville. We're working on a big, the LabMag KMag project, which is New Millennium Tata Steel. It's a big iron ore project also in the Schefferville area. Century Iron Ore Duncan Lake project is another iron ore in northern Quebec. We just finished a scoping study on a lithium project in Quebec. Just some other on the list here. Big one here in India that we're doing for the Steel Authority of India. It's technical assistance for an expansion project that they have. And here's dots all over the world that MetChem's done some work. So now on to the presentation for Ressource Ariannes. So I'm going to introduce the company, Ressource Ariannes, the Lac à Paul project, history, location, highlights from the pre-feasibility study. There's going to be a 4-minute promotional video to give me a chance to rest my voice. Then I'll get into the mine planning, block model, pit optimization, pit design, pushback design, mine plan, and fleet requirements. So Ressource Ariannes, basically it's a Canadian mineral exploration company that was founded in 1997. The stock symbol is DAN on the Toronto Venture Exchange. Some projects that Ressource Ariannes has, of course, the Lac à Paul Phosphate project in the Saguenay region. That's their most advanced project. They also have some other deposits, Opinaga, which is a gold deposit in James Bay, Quebec, La Dauversière, El Rey, they have a big gold-silver deposit in Mexico, and some other deposits that they have. So some history about the Lac à Paul property. It was discovered in the late 1990s. It was originally explored for nickel, and they found phosphate and titanium. There was a scoping study complete in 2010, pre-feasibility completed in 2011, which is what the presentation today focuses on, and they're hoping to go into feasibility study in the fall of 2012, with production scheduled to begin 2015-16. Oops. So here's a location showing the property. So we have Canada in yellow, with the province of Quebec in green, and this is the Saguenay-Lac-Saint-Jean area, which is about 500 kilometers north of Montreal. There's the cities of Chicoutimi, Saguenay, and Jonquière, and Lac-Saint-Jean. The project is located about 200 kilometers north, and there's a very good graveled forestry road which accesses the property. And there's two very large hydroelectric dam facilities. The Chute des Passes is 35 kilometers from the property. And then the concentrate that will be produced, the phosphate concentrate, will be either loaded on rail, which can access the North American markets, or there's a port at the Saguenay to access international markets. So some highlights from the pre-feasibility study. The proven and probable mineral reserves are 307 million tons at 6.6% P2O5. There's two open pit mines, the Paul and Manwan pits. They have a strip ratio of approximately 0.8 to 1. The annual production would be 2 million tons of concentrate, grading 39% P2O5. The mine life is 25 years at 33,000 tons per day. Initial capital investment, $649 million. Operating cost, $98 per ton P2O5 concentrate. And the selling price that we used was $175 a ton P2O5 concentrate. The NPV at a discount rate of 8% was $648 million pre-tax and $362 million after tax. 5.2-year payback period. So now I'm going to play the video. It just goes into a little more detail on the project. It was a video prepared by Ressource d'Ariannes.
Ressource d'Ariannes. A large deposit of phosphate rock in the heart of Quebec could start being mined just when a global demand for phosphorus is reaching an all-time high. Sitting about 200 kilometers north of the Saguenay-Lac-Saint-Jean region, the Lac à Paul deposits of apatite could help prevent a production deficit due to hit North America in the next few years. Preparations to mine these remarkably valuable deposits are underway in one of the most dynamic areas of Quebec. About 300,000 inhabitants occupy this vast territory that spans close to 100,000 square kilometers. On the socioeconomic level, Saguenay-Lac-Saint-Jean contributes to developing excellence standards in a variety of key sectors, such as aluminum, niobium, lumber, genomics, electrical energy, and tourism. Products derived from phosphate concentrate are used mainly to make fertilizer for the agricultural industry. Related to potassium hydroxide and nitrogen, phosphorus is essential for plant growth and helps increase the yields of a variety of grain crops. Phosphorus is also used in the production of food supplements for animals, preservatives, corrosion deterrents, and certain beauty products, as well as metallurgy. Over the past few years, the uses and the price of phosphorus have been growing constantly, due mainly to an increase in the world population and the use of fertilizers for biofuel crops. This chemical element is essential for all known forms of life, both animal and vegetable. It's also indispensable for living cells, and there's no known substitute for it. 3 separate deposits have been identified on the Lac à Paul property: Zone Paul, Zone 2, and Zone Manouan. These 3 deposits contain over 400 million tons of minerals that could be processed on the site to extract phosphate concentrate. It's a top-quality concentrate with a 39% P2O5 content. It's also very pure. The rare contaminants it does contain are always detected at very low levels. The characteristics of this phosphate concentrate compare extremely favorably to sedimentary deposits in other parts of the world. The Lac à Paul deposits can be reached taking Chute des Passes Road currently used for non-standard forest transport. This road makes it possible to carry phosphate concentrate to the city of Dolbeau-Mistassini. From there, the material could be transferred and shipped by rail to North American clients or to overseas clients via the Grand Anse Sea Terminal. This terminal is an excellent storage area for a variety of merchandise heading for overseas export. In the winter, the Canadian Coast Guard's icebreakers keep the Saguenay Fjord open for ships, so the port is in operation all year long. In terms of energy, the Chute des Passes or Parabanca Cat hydroelectric plants can supply all the energy needed to process the mineral. They're only about 40 kilometers from the future mine site. There are currently enough known resources in the Lac-Opal deposits to consider building an open-pit mine with a lifespan of approximately 25 years. The development of this mine would create close to 300 jobs. After the mine closes, the site will be rehabilitated and renaturalized. On the socio-economic level, this mine is sure to create economic spin-offs that could only be beneficial to the region's population. The Quebec mining company behind the Lac-Opal project, Ressource d'Ariannes Incorporated, is based in Chicoutimi. On the TSX Venture Exchange, its shares are traded under the symbol DAN or DAN. Ressource d'Ariannes feeds the future.
Okay, so now I'll get into more of the mine site stuff and the mine planning. This is a site layout. So we have the road coming in, the 200-kilometer forestry road. The plant site is located here. This is the Lac-Opal deposit, the limits of the open pit mine. This is the Manoine deposit. It's about 8 kilometers from the plant site. This is the proposed tailing storage facility. And then there's a few waste dumps, the north waste dump for the Paul deposit, the south waste dump, and the Manoine waste dump. And then the name Lac-Opal it's the name of this large lake here, which is Lac-Opal. That's where the name of the deposit comes from. So the block model, so MetChem received the block model from a geological consulting company. We can see here it's colored with measured resources in red, the indicated resources in green, and the inferred resources in yellow. And you can see that the ore is very close to surface. There's a few meters of overburden on top of the ore. So here's a typical section. And you can see here the topography and again the several meter layer of overburden. Now what was interesting with this is that, as I say here on the bottom, a block can contain overburden, waste, and ore, so 3 different types of material. So that made it a little complicated, so my solution was to use a multiple zone block model. So what I had was, I had an item in the model called Zone A. So if a block contained measured resources, the Zone A value was coded as 1. If a block contained indicated resources, the Zone A value was coded as 2. And for inferred, the Zone A value was coded as 3. And then I had a Zone B value, where if a block contained overburden, the Zone B value was coded as 4. And if a block contained waste rock, the Zone C value was coded as 5. And I'm going to mention, it was Justin Smith that, with tech support that helped me get the model coded like this. So here we're looking at a typical block. So we can see that this block contains some air above topography, and then it contains overburden, and it contains ore. So the way this block was coded, it had a resource value of 2 because it contained indicated resources. And then the Zone A value was coded as 2. The Zone A percent was 34. So 34% of this block is measured indicated resources. The Zone B value was 4 because it contained overburden. And the Zone B percent was 45. So 45% of that block is overburden. And then the remaining is the air above. The P2O5 grade in that block was 4.35, and the TiO2 grade was 4.25 here. So I also had to create these dummy values so that PitRes would run properly. So I had a P2O5 A, B, and C, but of course the only value that mattered was the actual grade. There were no grades for the overburden and waste, but we needed to create this for PitRes. So now I had multi-runs to code the blocks. So this is a multi-run how I coded all of the zone items and zone percents. So the zone A percent took the ore percent value, which came from the geological consulting firm. The zone B percent, I had a surface, a topography surface, and an overburden surface. So using the file 13 model view, I coded the zone B percent. The zone C percent was naturally the topo percent minus zone A percent and zone B percent. The zone A item took the value of the resource, which was either 1, 2, or 3, measured, indicated, inferred. The zone B item, I made it equal 4 for blocks that contain overburden. So if they had a zone B percent value, then they got a zone B equals 4, and zone C for blocks that have waste. And then I coded those dummy values for the phosphate and titanium grade for the ABC. So that's how I set up the block model with the multiple zone percents. The next step was to run the pit optimization to determine the economic limits of the deposit. So this is the multi-run that I had for the pit optimization. And what we did is we ran 10 simulations at different prices to present a curve to see the sensitivity of the price. So I had items in the model. I had cost, rev, and net, and cost 1, 2, 3, 4, 5, rev 1, 2, 3, 4, 5, net 1, 2, 3, 4, 5, up to 10. The first thing is I reset those items. The next thing is I code the cost for ore blocks. So we'll see what that user calc looked like. It might be a little small to read from the back, but it's basically a user calc with a lot of variables. The variables down here, so I had the mining cost, processing cost, pit slope. Well, actually, the pit slope comes in later. The price, the grade of the concentrate. So all of those variables go into the formula, and I run that 10 times to calculate 10 different costs for the 10 different selling prices. 10 different, I shouldn't say, the revenues, 10 different revenues. Anyway, the next is to code the cost for the waste blocks, code the revenue, code the net, which is the revenue minus the cost for each block, and then I run the Lurch-Grossman MS economic planner. So now that I've generated my Lurch-Grossman shells, the next thing was to run pit res. So again, I had a multi-run to do that, and I created a zone input file which contained the density and the cutoff grade. So the way I set up the zone input file was using the pitzone.dat procedure. So I have, this is the name of my zone input file. I have the grade of phosphate, and then I add the cutoff grades. So this is the density for each zone. And this is the cutoff grade, 2.43, which was calculated outside of MineSight as the economic cutoff grade. So this is what the zone input file looks like. And that's used in the pit res. So the next thing is the pit res. So this is the way the pit res was set up. It's a multiple zone model. So I had 3 zones per block. And then I entered the items here. And then this is the last panel of pit res, which for me was very complicated to set up, but Justin helped me through it. And all the boxes were checked correctly so that pit res was run properly. And then I create a CSV file, which I can enter into Excel pretty quickly. So this is what the CSV file looks like. You have the measured tons and grades, the indicated tons and grades, the inferred tons and grades, overburden tonnage, waste tonnage, and this is the waste material below the cutoff grade. I just plug that into my nice fancy table in Excel, and I'm good to go. So once the pit optimization is done, the next step was the pit design. So I did a pit design following the economic shell, and I used a pit expansion tool to do this, to get the ramp with the switchbacks. Once the pit was designed, the next thing was to design pushbacks. I did not use MSSP for the pushback design. I did it manually. I just chopped up the pit into 3 evenly sliced areas. So these are the 3 pushbacks that I designed. And here it is in 3D view, the 3 pushbacks. Then I did the mine plan. Normally I use IP for my mine planning. I didn't use IP on this project. I basically just created surfaces and ran the reserves to make sure I had the tons and grades for each period. So this is just a typical table here showing all the years and how much concentrate we're producing, the tons of ore with the grades, and the waste split by overburden and waste, and the stripping ratio. And then this is just a end of period map showing the pit advance. We're advancing pushback 1, and we've started pushback 2. And when we go into feasibility study, I think we'll get a little more involved either with MSSP or MSSO to do some more optimization. We also have the 2 deposits that I mentioned, so maybe we can mine both of them at the same time to do some better blending and maximize the NPV. And then here's an end-of-period map showing this is the Paul pit with the waste dumps and the Manwan pit. And then the final slide here is just the fleet requirements. So then, of course, as part of the pre-feasibility study, we calculated the fleet required and the OPEX and CAPEX to carry out the mine plan. So for this project, we had 22 140-ton haul trucks, 2 RH-120 shovels. We had a Komatsu 900 loader, 4 drills, support equipment, and then we also calculated the number of trucks we would need to transport the concentrate from the mine site to the port facility. So we had 115-ton haul trucks, and we had, road trucks, and we had 28 of them. So that concludes the presentation. If anyone has any questions.